Okay, let's get started. We're gonna just do a bunch of examples today. In the past couple days, it's been fairly theoretical, right? We did a bunch of examples, but what we were trying to do is sort of illustrate some of the theory behind what we're doing. Oh, and there's little Goosey. Hey, buddy. We started looking at just like what does it actually mean to add two fractions? Like what does that actually look like? How do we do that, and why do we do what we do? And we kind of started to look at slightly more complicated examples until we actually did one example that was just full-blown, like, challenging math question. And we did, I think you did one, and then I gave you some homework. So let's try a few more examples. So I got one here. Simplify. Yeah. Okay. I'll do this example here, and I'm gonna get you to start off by doing it. Okay, gonna kind of try something a little bit different. So this time it's your turn. It's your turn to try a question. That's how we're gonna begin. So I'm just gonna write try this. Try this. So we're going. I want you to add or subtract. Okay, so in this case, question 1, you are going to, subtract. So I've got 2x squared minus 7x, all over x squared minus 100. X squared minus 100. And we're going to subtract x squared minus 2x plus 10, all over x squared minus 100. Okay, so I'm going to give you, let's say, 5 minutes. I'm going to give you 5 minutes to answer that one. There you go. And we'll see how far you get in 5 minutes. Okay, so get your pencils out and start attacking this guy. Here we go. Time's up, guys. Let's see how you did. Anyone finish?
Yeah.
Oh, all of a sudden you guys aren't in my earphones anymore. Give me 1 second.
Whoa. That's big.
There you are. Now you're back in my ears. That's much better. Okay, so you guys finish? Yeah, these questions are kind of fun. I enjoy these questions. Okay, so let's try them. The thing I like about these questions is that it starts off, you know, looking kind of like a hot mess. You know, like it looks kind of gross. It's like all this stuff, and then you start adding it and then piecing it together, and it's like, oh, and then you get this nice little package, and you know, and then it turns out to be very simple, right? So it's kind of like cleaning up your room or something, right? It's like it's a total mess, and then you start putting stuff away, and then when you're done with it, you're like, oh, I've got this nice, perfectly clean, tidy little room. So let's clean our room. So these have the same denominator, so we're going to subtract one from the other. So let's just start off with the denominator. The denominator stays the same. We've got x squared minus 100. Now I'm going to start subtracting the like terms. So I've got 2x squared minus x squared. So that is x squared. I have negative 7x minus negative 2x. Let's just write that on the side here, just so we're not confused. Minus 7x minus negative 2x. That's the same thing as minus 7x plus 2x, or in other words, negative 5x. So we've got minus 5x, and then finally I've got, well, nothing minus 10. So this should be minus 10 up here. So there you have it. So we're looking for two numbers whose product is negative 10 and whose sum is negative 5, if we were to go ahead and factor that. I don't know if we can. Did any of you guys get anything here? Did you do anything different, or is this just kind of a messy question? Just factor the denominator. Okay. Yeah, because I'm thinking that this isn't going to simplify very much further. So this is equal to, well, let's do x squared minus 5x minus 10 over, well, this is a difference of squares, so it's x plus 10 times x minus 10. And yeah, it's too bad. It looks like if only, I wonder if I wrote the question down wrong. No, I didn't. Negative 7x, negative 2x. Yeah, you know what? Here's another math teacher luxury. I'm gonna change this problem. I'm gonna. So this is the answer to the initial question. Okay, this is the answer to the initial question. I want to make this a little more interesting. Okay, so what I'm going to do is I suspect now. Just to give you some background on myself, I have spent a lot of time making math problems. A couple of years ago, I was hired to build a website that was intended to help students in first year calculus, and my job was to make worksheets, and I made probably over 1,000 questions, and it was extremely tedious. But the reason I'm telling you this is because I can tell you firsthand that it's really easy to have an idea for a question, and you want the student to do a certain task, and you can very easily come super close to getting the student to do a specific task. But if you kind of mess up a negative sign or a minus sign or something like that, then immediately the question is boring. I would consider this not to be the most interesting question. I think that this question would be much more interesting if we change this minus sign into a plus sign, And you'll see why. So here I'm going to have, so if, like in an alternate universe, if this was the question, then what we would do is we would have negative 7x minus 2x, which would give us negative 9x. And now the problem is going to be much more interesting. So we've got negative 9x, because this, as it stood before, this top one, that's not factorable. I mean, you could probably use the quadratic formula and get some kind of radical and pull that out, but that's not very interesting because it's not going to be plus 10 or minus 10. So my guess is that the person who made this question initially wanted this to be negative, because they did have a minus sign here. But I think what happened was when they made this question, they forgot that there's a minus sign right here. So my guess is that they intended to have this as positive, which would give us a negative 9x here, in which case now we can start to factor this. So let's factor this. Now this is factorable. So we're looking for two factors of negative 10 whose sum is negative 9. So of course that's going to be plus 1 and minus 10. So this is going to be x plus 1 times x minus 10. And this is x plus 10 times x minus 10. And then this cancels with that. And then look, isn't that a cooler question? So this is x plus 1 over x plus 10. So that's what I imagine the authors intended us to do. But it was probably a little typo. And like I said, I can tell you firsthand, it's super easy to make a typo when you're making a math problem. You can imagine all the places that you can make a mistake or make a typo when you're solving a math problem. I can tell you that it is 10 times easier, and that's not hyperbole, I'm not exaggerating. It's at least 10 times easier to make a mistake when you're making a math problem. It's very difficult to make a math problem, especially when you have this idea of all the things you want the student to do. Because you can see that the first version of this problem kind of just stopped abruptly. It was kind of like, okay, and now we're done. But if you just change one sign, then immediately, boom, the whole question sort of follows this process that we've been doing in class this whole time. So that's cool. Let's try one more question. Let's try this one. Hopefully there's no typos on this question. Let's see here. Yeah, because a lot of the time I can make up a problem on the spot. I feel confident making up problems on the spot, and I do it all the time. But for these types of problems, I can't do that in my head. I can't make these problems up in my head. These ones have to sort of be prefabricated. Yeah, so that's why I'm kind of following the book here, because they've got some really good examples. But even still, there's still going to be some typos in the question, because I'm certain that they wanted us to simplify this and cancel out common factors, because that's a huge topic in this chapter. Anyway, I'm getting distracted. So 2x minus 3, we're going to add or subtract 2x minus 3 over x squared plus 5x minus x plus 9 over x squared minus 4x minus 5. X squared minus 4x minus 5. Okay? So I want you to add or subtract this guy. So remember, we need a least common denominator here. So try to find your least common denominator, work from there. Okay? All right, so let's do, I think this one's going to take a little bit longer. Just on the Discord or in YouTube, if you wouldn't mind just telling me, was that too much time or not enough time, the 5 minutes for this last one? Okay, 5 minutes for this one. I'm thinking this is a harder problem. Like, do you think 7 minutes will be too much time? I don't want to give you too much time. 6 minutes it is. Okay. And YouTube people are saying about the same thing. Yeah, that was a good amount of time. That was enough. Okay, so we'll do 6 minutes for this. Okay, I will come back in a couple of minutes and see how you're doing. Mm-hmm. Is there something funky about it? Mm-hmm. Well, wouldn't it be x minus 5x plus 1? Oh, and the other one is x plus 5. Brutal. I just verified, I just looked at the solutions. Oh, jeez. I got to start vetting these problems. I didn't think this would be a problem. Yeah. Because the solution indicates that you should have x plus 5 times x minus 1. So, and I definitely copied the question down correctly, yeah. I'll have to send the publisher an email. So what we're going to do is, again, I'm sorry that we're just kind of figuring this out at the last minute here. I'll do this problem for you. So my guess is that you were probably able to factor these and that you weren't really able to find a common denominator that made any sense. This should be positive. This should be positive. If that's positive, then this should work out a little bit more nicely. So what I'll do is I'll solve this. And sorry if you feel like your time was wasted there. I'll even show you when we're done that I did actually copy this correctly from the book, and the book is confirming that they made a mistake because their solution is a solution to this question, which is interesting. So, like I said, it's very easy. Like I know it's easy to get annoyed by this type of thing, but just having been on the other end of these kinds of mistakes, they're very hard to catch. They're very hard to catch. Okay, especially, I mean, like if you were to look at this book, and I'm sure on the first page there's a list of authors. There are 1, 2, 3, 4, 5 authors to this book, mostly from Alberta and Ontario. And then there is a full page of acknowledgement. So there's like, it's a big deal to make a textbook. Like, it is not easy at all. Like, it's a tremendous amount of work. Like, you think of how hard it is to read a textbook. You know what I mean? So yeah, it's annoying, yes, when there's typos in a question, but I kind of feel for them at the same time, because this is actually, it's really hard to make a good math question. And I think this is a fairly new book. Usually books have several editions, right? So each edition they correct errors and mistakes and things like that. And that's typically the only difference between like the 5th edition and the 6th edition of a book, is that there's fewer mistakes. Anyway, let's solve this sort of fixed problem. So I'm gonna factor this guy. So this guy is x times x plus 5. I'm gonna factor this guy. This is x minus 1 times x plus 5. Okay, that looks a little bit better because now we have an x plus 5 in both of them. So the LCD, I should actually bring that down. And maybe what I'll say is that this is, I'm going to factor. That's what I did on this line, is I factored. And on this line, I'm going to find the LCD. Well, I definitely need x. I definitely need x plus 5. Okay, right? Like that's that one, and that's that one. I also need x minus 1. Got x minus 1, right? That's that one. But I already have x plus 5. That's already there. So I don't need it twice. I only have one x plus 5 that I need. So the least common denominator is x times x plus 5 times x minus 1. So let's do that. So what I'm going to do is I'm going to copy out the whole question again. I'm going to say 2x minus 3 over x squared plus 5x. I'm going to give myself a little bit of space because I'm going to be adding some stuff to it. I'll have x plus 9 over x. Oh, and I should actually have these factored, sorry. X times x plus 5. And this one is, x minus 1 times x plus 5. That's better. That'll make it a little bit easier to know which terms I have to multiply. So this first one, I've got x. I've got x plus 5. I need x plus 1. So I'll do x minus 1. I need x minus 1 on the top and the bottom. Great. And on the second one, I've got x minus 1. I've got x plus 5. I need x. So I'll multiply by x over x. All right. So now we can actually just start doing some algebra and expand some of the stuff. Something important to remember is that we need brackets over here because we're multiplying by the entire numerator. So for this first one, we have, well, 2x times x, that would be 2x squared. 2x times negative 1 is negative 2x. Negative 3 times x is negative 3x. And negative 3 times negative 1 is positive 3. Then, I'll just have one big fraction. I've got x times x, which is x squared. Maybe I'll do this second fraction in a different color. How about purple? So I've got x times x, which is x squared, and 9 times x, which is 9x. Okay, great. And in the denominator, I just have that common denominator now. I'll do that in red. That is x times x plus 5 times x minus 1. And now I can clean up that numerator. So let's think about some of the common factors that I have. Well, I've got 2x squared and x squared. So I'll make that a little bit smaller. And x squared, so that would be 3x squared. So I've got 3x squared. Now let's think about all my x's. Let's make that blue, how about? Okay, so I've got negative 2x, negative 3x, and 9x. So I've got negative 5x plus 9x is 4x. So I've got plus 4x. And let's do green for the constants, which is just plus 3. And red will be the denominator. Okay, so the denominator is x times x plus 5 times x minus 1. And as always, we're just going to leave factored. Okay, so we're going to leave this denominator factored. Okay, this looks good so far, I think. I wonder if we can cancel any common factors. So let's see if we can factor this one. I'm not sure if we can. I don't think that this is factorable. I don't think I've done anything wrong. It is 3x squared plus 4x plus 3. Yeah, because that's negative 5 plus 9 is 4. Do you see something? Did I make a mistake? Well, subtract. Oh, yes, it was to subtract. There it is. Therein lies the problem. Thank you. See, I made a big mistake there. That's a minus sign. That's supposed to be a minus sign. My bad. So that's where my error was. So that shouldn't be too hard to fix. So this, all I have to do is turn that into a minus and that into a minus. So let me pull out the purple again. That's, oops, minus, minus, right, because I'm subtracting this now. So I was subtracting that second term. So that's fine. What else? So that changes this whole numerator. So let's just do it all in one color. That was kind of annoying. So 2x squared minus x squared, that's just x squared. I still have, okay, so negative 2x minus 3x, that's negative 4x. Negative 4x minus 9x. Negative 4 minus 9 is negative 13, so I've got minus 13x. And I've got a constant of 3. Still doesn't really help me. Pardon me? $14. Yeah, 5 and 9 is 14. Thank you. Struggling today. I still don't think that helps us though. Like, I don't think we can factor that. Let's see here. Make sure I didn't make any mistakes. I don't think I did. 2x minus 3, x squared plus 5, x squared minus 4x minus 5. But we changed that to a plus 4x. Yeah, you know what? This book is proving to be unreliable, because this isn't even close to the solution that they have in the back. I checked it after looking at that last question, and 6b. Yeah, they're getting x squared plus 4x. So, you know what they meant to do? They forgot another minus sign. Okay, there's only so many mistakes that they can make before I get actually annoyed. Because this was supposed to be a minus 9. Hey. So this is supposed to be minus 9. Isn't it great to be a math teacher? You can just change the problem until it works the way it's supposed to. And if I add 9, then this gives me plus 4x. Ta-da! I can factor it. So yeah, let's factor this numerator. So this gives me x plus 1 times x plus 3. Sorry, I'm hoping that this isn't like totally confusing you. I would totally understand if you found that confusing, that I just changed the question. If I were you, I'd be maybe a little bit annoyed. And that's perfectly valid. You can be annoyed with me. I'm just trying to make the problem work out nicely. And even then, we can't factor any common factors, but at least we can factor the numerator and determine that we can't cancel any factors. So and that's supposed to be x plus 1 and x plus 3. What am I doing? X times x plus 5 times x minus 1, and we're done. The non-permissible values, let's just do that for fun. It's x equals 0, x equals negative 5, x equals 1. So what I'm learning from this is this book is becoming a little more unreliable. And I'll even show you. I didn't copy the question down wrong. Look at this. Okay, here we go. I didn't copy it down wrong, right? Those are the first two questions. I'll take a little snapshot and then we can just insert that in here. There we go. And then I'll look at the book. Hold on one sec. Or at the back of the book, 6.3. I feel like I have to prove to you that I'm not being unreliable here. I blame it on the book. And then the book, take a look at this. Oopsies. This is kind of a three-handed operation here. The book here is, come on, take the picture. Okay, there you go. I'm gonna use this photo and yada yada yada. Can I move this over here? Yeah, there we go. Okay, so did I copy the question down correctly? I think so. X squared minus 3 over x squared plus 5x. And yeah, see, like I said, they had a plus here. A plus here. It worked much better as a minus. In fact, if it was a minus, and plus this should have been a plus. So they basically mixed these symbols up. That should have been a plus, that should have been a minus. So that's where they made their mistake. And in the solution, this was 6b. Oops, 6b. So they had, yeah, x plus 3, x plus 1, right? So they must have made that mistake. And same with the other one. I don't think I copied that question down wrong. It was x squared minus 7x. Here, can I do this? There we go, yeah. So it was x squared minus 7x over x squared minus 100, x squared minus 100, minus x squared minus, and then we had to change it, right? We changed it to plus so that it actually factored. And then, yeah, and then the solution to the first one was x minus 1 over x minus 10. So they probably just switched the sign for something else. So this book is proving to be a little more unreliable than I would have liked. So that's too bad, because I was starting to, I like the questions that they intended, but it's too much trouble to have to go back and change the question after we're done. So I'll use the actual official textbook. This one has been, this actual, like the real textbook has been fairly consistent. I don't think I've had any issues with any of these problems, but two in a row is pretty bad. Like, that's no good. So we'll go to 6.3, and let me give you a quick little exit slip. I think yesterday, what did I do? The first 3 questions as homework? So, yeah, I think it was the first 3 questions. 6.3. Okay, I'm going to get you to do, for your exit slip, 6A. So your exit slip for today, oopsies, exit slip is 6A, and that's on page 336. Page 336, and since we're here, I'll take a little picture of it. Not before showing you the cats. Excuse my lunch there. They're just taking a little cat nap. This is where they spend 90% of their day, is just lying on the couch, snoozing. And they curl up together, and sometimes they wake up and then they just start cleaning each other. So yeah, that's what they do all day. Yeah. There's my record player, my little record collection. We have to put a blanket on top, otherwise they chew on the records, and that's not okay, so I have to put a blanket on top. And that's the, yeah. It sets many records, and it turns the records too. Kima. K-I-M-A. Kima. Yeah. So, hey buddy. Okay, 6A. Okay, where's 6A? Here's 6A. And let me put 6A up on here, just so if you're too lazy to crack open your textbook, you have no excuse. It's right here. And 336 says so right there. And shoot. 336. Crop. 6A. Here you go. There you go. So there it is. Remember, you may need to use Desmos to format your answer. Oh yeah, someone else asked on YouTube too. What's the cat's name? Yeah, Kima and Goose. Yeah, so the exit slip is to do this question, and for homework over the weekend, just a couple questions. I'd like you to do questions 6 and 7. Just those 2. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 questions in total, because it's like this. Question 6 is A to F, and question 7 is A to D. So they're multi-part questions. So there's 10 in total. 10 total. So hopefully that keeps you busy. I believe the assignment is due today. Is that right? I think it's due Friday, right? Which is today. So you have until midnight or 11:59. So far I haven't heard any issues with it, so I can assume it's going okay and there's no major concerns. So yeah, let me know if, looks like, oh wow, 12 of you have already turned it in. Holy smokes. I didn't even, haven't looked at it yet. So that's awesome that so many people were able to hand it in already. And did anyone have any issues uploading any of their work? Were you able to submit it okay? Looks like people are submitted some PDFs. All right, that makes me so happy to see a PDF. It is so much easier. Yeah. Because you have to understand that physics is just okay, here, I'll quote a famous mathematician, and I want to get the quote right, so let me look it up. Nope. Okay, well, where is it? Where is that? Okay, so there isn't like a fancy long quote. I thought maybe there was like a well-known quote, but colloquially, Carl Friedrich Gauss. You may have heard of this guy. Here, I'll pull his picture up. Really smart dude. Carl. I'll just call it Gauss. It's easier to Google. Carl Gauss. This guy, smarty pants. We owe probably like, I don't know, 30% of all of mathematics to this person, which is a lot. Math is pretty big. He solved a lot of major problems in algebra, and algebra is the way it is today because of a lot of his work. And anyways, he said that mathematics is the queen of the sciences. So that is to say that science would be nothing without mathematics. So why did I put a physics question on the math assignment? Well, that's because physics is just math. That's all it is. So yeah, I kind of wanted to hopefully let you see that there's a connection to these things, and it's also important to know that what we're doing here isn't just like an exercise in like your mathematical abilities. What we're doing is relevant to the sciences, right? Like this has context in the real world. This isn't just about symbols and playing around with like shuffling numbers around. What we're doing does actually have real world applications. So I thought that I would throw in a little physics question. So I'm gonna go. You guys have a good long weekend, right? We've got Monday off. So yeah, tomorrow's an in-service. So, or sorry, not tomorrow, but Monday's an in-service. So yeah, I'll be in a Zoom conference with. Actually, not Zoom. We're not allowed to use Zoom anymore. We're using Google Meets. Yeah, we'll be in a Google Meets conference, the math department. So yeah, we're gonna be talking about all sorts of fun stuff. So that's what I'm doing on Monday. But you guys can sleep in and do whatever you want and hang out. You got your math assignment done, so you don't have to do any math. So you get a true long weekend. So isn't that nice? Anyway, yeah, I'll sign out. I'll talk to you guys on Tuesday. Have a good one. Bye, guys. Yeah, you too. Bye-bye. And goodbye, YouTube. I will see you. Oh, what's the other cat's name? You guys, yeah, I know. This guy has one photo. What's with that? Anyway, okay, bye-bye, YouTube. Have a good long weekend. Talk to you Tuesday. Bye-bye.